In a survey of 23 people were asked how much they spent on their child's last birthday gift. The results were roughly bell-shaped with a mean of $50 and a standard deviation of $6. Find the margin of error at a 90% confidence level. So the first thing to realize is that this is because we're talking about mean and we don't know anything about the population mean, the population standard deviation, this tells us that we are dealing with a t distribution. Spell this, t distribution. So the idea is if we put our confidence level in the middle, 0.9, then there's 10% left over for the two tails. And if I split that into the two tails, then I've got 0.05 here, 0.05 to the left. So altogether, that should add up to 1. So the first thing we need to do in order to calculate the margin of error is get our critical t value. And then we'll multiply that by the sample standard deviation divided by the square root of our sample size. So to look up the critical value, I can either use a table, which I'll do first, a t-distribution table. The other thing is I could use some technology, and I'll use a spreadsheet. So first of all, to get the value off of the table, note that there is 0.1 left over after our confidence level, 0.1 left over for the two tails, or know that 0.05 is in one of the tails. So I can either look up 0.05 in one tail or 0.1 for both of the tails. Either way, that tells me I'm in the fourth column over here. Then, to figure out what row I'm in, I need to know my degrees of freedom. And we're using n-1 to calculate degrees of freedom, which in our case is 23 minus 1. So that leaves me with a degrees of freedom of 22. So we'll go down to row 22 in that fourth column, and that will tell me my critical value, 1.717. And now we simply multiply this times the standard deviation, which we are told is $6, divided by the square root of our sample size. On a calculator, that gives me 1.717 times 6 divided by square root of 23, let's call this 2.148 as my margin of error. Now, instead, I could do this all in a spreadsheet. So let me, first of all, find that critical t value. And that I'm going to use t.inv, and this function t.inv, that gives me the critical value that has this probability that I'll plug in to the left. So I need to think about how much, I want the positive over here, how much area is to the left of that? Well, it's the 0.9 plus the 0.05. So I could plug in 0.95. Or I could do the addition here, 0.9 plus 0.05. The other thing I could do is I could get the negative critical value by plugging in just 0.05, and I'd know that I need to change the critical value to positive. So I'll do this first, and then I'll come back and plug in 0.95. Now my degrees of freedom we said was 22. Plug that in, and I've got negative 1.717. I could make sure that it gives me the positive by wrapping this function in an absolute value, ABS function. That'll force it to be positive, or I just know that it's going to be positive. So the other option is, without this absolute value function, I know that there's actually 0.95 to the left of the positive critical value. So that's still going to give me positive 1.717. All right, and then I could come over here and run my my margin of error formula. So I'm going to point to where I have my critical value, that's my 1.717, and then multiply times 6 and divide by square root of 23, 2.148. And that's my margin of error.